for the introduction. Welcome everybody. Today we speak about ASAM SOVD. SOVD stands for Service-Oriented Vehicle Diagnostic, and you see it's a diagnostic API for software-defined vehicles. Today we have 4 parts prepared. First of all, I will give you an overview about the basics of SOVD, which technology is used, what is SOVD. Second, we will look in the functionality of the version 1.0. The version 1.0 was published in June 2022, and it's for ASAM members and non-members available via the ASAM homepage. Afterwards, we look into the new functionality of the version 1.1. And in the last part, we speak about the collaboration with ISO and the timeline. Let us start with the basics. Why was SOVD introduced? Because we have now in the domain of autonomous driving and others development a lot of new HPCs inside the car. An HPC, you can have the functionalities of a virtual machine, multi-core, parallel applications, dynamic resources, and very important, you have an operating systems. And based on this, a lot of applications are running on such an HPC. I normally compare this with a mobile. You do not know which apps you want to have at the end on your mobile. Dynamically, you bring in new apps or you remove apps and so on. So we see for the future the vehicle as a simple IoT device, and the main task is, and this you can compare with your personal computer at home, we have with this agile exchange of applications, we must analyze the functionality of these applications while they are running. And this changes a lot, and therefore we work not anymore with a byte-oriented access. And you see here on this picture, SOVD was introduced for 3 scenarios. The main scenario, which you know from the past, is the so-called co-located scenario. This is the scenario which is used in the workshop. So in the classical workshop, your fault memory is read out and the people looks for the errors inside. But besides this, we use also SOVD for in-vehicle use cases. This means the client can be in the car implemented, which can be then used for predictive maintenance. And very important, we use SOVD also for the remote use case, where you have the possibility of remote assistance and the possibility of fleet management. What is used in SOVD? First of all, in SOVD, no new technology was developed from ASAM. So we use here simple an HTTP REST approach. And this approach means that you have more or less 4 methods. It's called the so-called CRUD methods, which stands for create, read, update, and delete. And that you found if you look in the standard what it is. Create is the post, read is the get, update is the put, and delete is the delete. ASAM have distributed the functionality in such a way that you see here. We have so-called entities. And we have as entity the SOVD server, which is more or less the entry point. And then we have in this SOVD server components. A component, you can also say it's a device, but we want not use the term device, so we call it component. A component is at the end a HPC or an ECU, and the component, like you see it here, have subcomponents. Other view on this is an app. An app stands for application, and then we have the areas. The areas can have sub-areas, and we have functions. And these 5 entities which you see are the only things which you can use. And here we come also to a very important point. ASAM have defined the standard. The standard is something like a tool set. The content at the end is in the responsibility of the vehicle manufacturers. So how much apps you have in your car, how much components, ASAM does not define. You define it as vehicle manufacturers. This is like a toolbox which ASAM gives you. And now we come to this. On each of this entity, you can have so-called resource. And the resource I compare normally with a variable which presents the diagnostic content. And important is, with SOVD, you have access to a whole resource. You cannot restrict that you say, I take only a part of this resource. You take the whole resource, and it's task of the application to do the evaluation. So if you have a complicated structure and you need only one element out of this structure, then you take it out in the applications, and that's all. That's what we do. So the functionality itself is provided via resources, and the resources can support simple and complex data type, which means array structures and multiplexer as the complex data types, and the simple data types typically string, float, Boolean. The data are described with JSON, also not invented by ASAM. And here we work with the data on physical level. Nobody is interested to know from this bit to this bit in this byte is my temperature. For this temperature, I take a compute method. No, I want to know, is it now 25 degrees or is it 10 degrees? This I want to know if I read the temperature, in case that temperature is offered as a resource. We have the possibility that we combine each resource with a physical unit. And we have here used the ASAM concept of the representing of SI units and abbreviated units from the SI. Also, we have the possibility of metadata, and with the metadata, we can typically describe such things like max and min. So at the end, the resources are presented from the vehicle manufacturer, and also, it's very important to understand, ASAM have defined the standard, but no implementation. We work together as members of ASAM as we have developed the standard, but the implementation of the standard, that's the task of the suppliers. Here we have an overview about the functionality of the version 1.0, which is now public available. In the middle area, you have the functionality separated in two clusters. One cluster is the classic features like fault handling, reading and writing of data, configuration and control operations. This you know from the past from the MVCI server and the ODX data. New is here the HPC related features, handling of bulk data, access to logging information and software update. On the right hand side you see such basic services like authentication, authorization and security. We have not reinvented the wheel. Every OEM can use his concept for security. At the end, for each HTTP method, we use so-called credentials. And on the left-hand side, you see, and that's new, the capability description. The capability description is a JSON file, and this JSON file gives you an overview about the entities, the resources, the data types of the entity resources, the value range, keys, and so on. The capability description you can use offline. This means you have in advance everything available what you will find. There you have also an overview of which methods are available and supported. And we have also the possibility to use it as an online capability description. It's the same format, it's not different. Let's have a more detailed look to the functionality of the version 1.0. So we start here directly now with the capability discovery. So this is now the so-called generic approach where I go step by step and look what is available. I ask for the online capability description and ask then for the available entities and resources. Here you see an example which we will use further on in the other functionalities. You see here the server. You see a functionality which is called vehicle heels. You see here components. We have here driving computer, camera and power steering. We have some applications which we use then also for the other examples. Now we come to the fault handling. Of course, I know everyone knows from the past you want to read the fault. You want to know the details of the fault. The details from the fault are the so-called environment data. And you want to delete all faults or you want to delete only one fault. That's the idea behind. Data reading and writing. data reading and writing. And here we have some, first of all, we distinguish between so-called data categories. So it's current data, which are responsible for dynamical changing values. Ident data, these are parameters which are fixed normally in the vehicle. Then stored parameters which have read and write access, and sysinfo data which are for the system resource. And we have here the speciality. Normally you can only have and read access to one resource. This means if you have the resources Anton, Bertha, Caesar, you make read Anton, read Bertha, read Caesar sequentially. But you can also combine it to a so-called data list. That's a dynamical data list, because you say, I want to have now a data list which contains Anton and Caesar, and afterwards you make a read access to this two resources and receive the values in one step. Yeah, we have also the write of data. This is not for data list, and the data list of course must be created, so the data list is also deleted at the end. Here you have an example, and this example is very good because I told you, you are responsible for the structuring of the data. And you see here, maybe it's a car with 4 windows, and you see I have one resource for driver window, I have one resource for passenger window, and I have one resource for rear window data. And in rear window data I have a struct which have position left and position right. Of course you have the possibility, you can say, oh no, in my car it should be presented as 4 resources. The next one says, no, in my car it should be presented as 2 resources, one for the front with a struct for left and right, and one for the rear with a position left and right. And the next one says, in my car it's only 1 resource, and this resource contains then 4 elements in the structure. Again, if I have only 1 resource with a struct and all 4 elements are inside, I can read this resource only complete. And the evaluation says I need only from the front window the left position. Yes, and do it. Simple. That's all what you should know. Yeah, configuration. Configuration stands for manifest data or variant coding, and we separate here 2 possibilities. We can write and read the data as parameter, or we can write and read the parameter as bulk data. Bulk data is nothing else as a byte stream. Now operations, that's a bigger part, because the operations can be software functions or it can be I/O functions, and the operations you can execute synchron and asynchron. Synchron is very easy because in synchron you call it and receive the result. In asynchron, there the operation is running, and while this operation is running, you have the possibility to make more activities. You see, you have the possibility to reset to a default value. You can freeze the current state, or you can execute this state. And we have here introduced the so-called timeout. This means the timeout is then used for the time while the operation shall be running. So if the asynchronous operation must be normally stopped at the end, but with the timeout we can define how long the operation shall maximum run. We have the possibility of proximity proof. What does it mean? That's more important for the co-located use case, and we use a so-called challenge response behavior. This means in the capability description is described the challenge, and then the response must be given before the operation can be executed. Then, and this maybe you know from the past, some operations require special modes. And these modes, we have 3 possibilities. We can do it implicit, which is of course the best way, because then the vehicle or the server is responsible that the state is complete Z. We make implicit or hint-based. Explicit, I make it step by step from outside. I have to bring the vehicle in this mode where the operation can be executed. All the information is of course contained in the capability description. Or the third version is you call the operation and receive simply an error because you're on the wrong state. Yeah, and here you see also logging. Logging is not restricted to operations. Logging is maybe required that you have an exclusive access right to this operation and no second client can make something in the way. So now we come to software update, and that's totally interesting because software update is completely changed. And here again, I show you my mobile. On the mobile, you know, there you have only the choice. There comes a software update and you can say now or later. More choices you have not. And in SOVD, we make more or less the same behavior. So the update itself is complete controlled by the vehicle. But the vehicle says to you, by the way, I have now 3 software updates available, Anton, Bertha, Caesar. And you can then say, okay, I want to do the software update better. Important is the software update should be complete. This means if I make a software update to a component, all subcomponents must be contained. The configuration will be done. And we distinguish here only between 2 update mechanisms. One is the so-called automated installation of an update, where you have only one command and everything done. And the second step is where we distinguish between prepare and execute. So this means we have there a 2-step approach. That's the only thing what is done. Yeah, I told you that it will be in such a few an atomic step which shall be then run. And that's totally different if you remember that in the past you flash there 10 bytes, then 100 bytes there and so on. And at the end you make the configuration. That's complete out of this. Yeah, and here you see it. It's not called Anton, Bertha, Caesar. It's called here update 1 till update 4. And what you see here with autonomous, that's other specialty. This gives you something like, I would name it default update. In my example, it was Anton, Bertha, Caesar. And if Bertha is the default update and you want not to select if you make Anton, Bertha, Caesar, then you say simple, make the autonomous update, and you see it's only a reference to this update Bertha. Yeah, handling of bulk data. I told you we have there the possibility to write byte streams with the bulk data, and the bulk data categories are specific from the vehicle supplier. Here you see, for example, I have 3 categories, POIs, I have logs, I have maps, and you can select whatever you want to have. Then we come to logging. Logging is important. First of all, you should understand that the logging will be evaluated from the manufacturer and not in the workshop. We support 2 file types at the moment. This is RFC 5424, which is called syslog protocol, and the AUTOSAR diagnostic log and trace. And herewith we come now to the UDS, and the UDS is something which you see here. Yeah, and after UDS is introduced to have a better support of the UDS protocol, it's something where you see how the HTTP commands are mapped on the different UDS things. But this is only for the UDS fans interesting. I'm an MVCI man, and in the MVCI you have never spoken about UDS. This was the functionality of part 1. Before we come to the functionality of the version 1.1, let me summarize one more time the advantages from SOVD. And I think it's very easily visible when you look from the client side. And I told you I'm coming from the MVCI diagnostic server. And we take now the simple example that you want to read the temperature. With SOVD, in case you know that the resource temperature exists, you simply call get temperature and then you receive the value of 25 degrees Celsius back. In MVCI, you have to select a project. You have to select a vehicle information table. You have to create a logical link. You have to bring this logical link in the state online. Then you have to create a diag.com primitive. You have to start the communication. This means you configure this diag service. When the diag service is running, you have to fetch the results, and only then you will give me the temperature. Nobody wants to do this anymore in the future. He wants to have the temperature. He wants to set a pressure or something else. That's the task behind. And again, we have defined only an API, not the implementation. Data evaluation, I told you, is task of the consumer. And important is the vehicle manufacturer is responsible which entities and which resources are offered for you. But after 2022, the life was going on, and we come now to the current development in the 1.1. And one big new functionality, because go back to the temperature, I told you we have the possibility only to read the temperature with the get functionality. But I can also say I want to be informed when the temperature enters in range. For example, I want to be informed when the temperature goes into the range of 30 to 40 degrees. So I can have a lower bound and the upper bound. I can also say I want to inform when the temperature of 25 degrees is changed to 26 or 24. I can also say I want to be informed when the temperature is exactly 27 degrees. You see here the objects which are observable. This is not only data, this is faults, these are operations, scripts, updates and logs. This gives me also the possibility, especially for the operation, I can look when the status is changed. So, and we have here also not re-event the wheel, we use simple the server send events mechanism from the Open API, and we will be informed about with the event when the condition is true which we have specified. And besides this information, we have the possibility to write an entry into the log file. In the log file, we can write the trigger condition. We can write the value which is now happened, because it is important if you look for a state change, then you want to know the state. We can write a statically prepared marker text, and we can write a severity. This log file helps in case of software analysis a lot for the evaluation. We have the possibility to distinguish between single shot and multi-shot triggers. This means the trigger is used once or multiple times. We can define persistent triggers. This means after a restart of the server, this trigger exists and I must not redefine this. And we can give all triggers, of course, a lifetime. So come back to the temperature. I told you I can make get, which is the read, and that's all. And I can this cyclic do. But why should I do this? I can also say I want to have that the server does it cyclic. And here you see we support ranges between 100 milliseconds and 500 milliseconds because we say, and there was practical evaluations, if you want to have it more slow as 500 milliseconds, then you can do like I described, you can call get. After 1 second you can say again get, because the performance of the network is good enough to do this. And here is the same like for the triggers. We can define the duration, how long the cyclic subscription shall be run. Now, and this is most important, because I told you in today that we will also support legal requirements for the authorities. And therefore we have introduced a totally simple mechanism, because that's the same like with our standard. I told you it's a toolbox. Here we say a standard like the periodical technical inspection can introduce a prefix. we have used the prefix APTI, but it's not standardized. The PTI group can say it should be, they can use it, they can name it Anton if they want. And then they have to tag all the resources in the capability description with Anton. And at the end, I ask only which entities have tagged values, which resources in the entities have tagged values, and at the end I work then with my typical read, write, operations, scripts and so on with these tagged things. We support that more than one tag for one resource is possible. And this gives you, you see here that we have not only APTI, we have here OBD also for zero emission vehicles, we have tachographs in mind and so on. And ASAM will go to this authority bodies and speak with them after our standard, and we come to this later, is an ISO standard. Now we come to scripts, and scripts are used for diagnostic command sequences. Important is we have defined only an API, and we have not defined a script engine, and we have not the language standardized. That's totally different if you compare it with the MVCI server, where you have the so-called Java jobs. You can do in your scripts whatever you want, but you should, one thing not forget, for your script you need a credential. So at the end, the vehicle manufacturer is responsible if he gives you such a credential, and what is the content of this script. Because the script shall be not used for bringing in new functionality. New functionality you can bring in with your software updates. The script is something where you have a better analysis in the car possible for special cases which you want to do. And here you see that's why we have also that the script can be now, the script can be now and on restart, the script can be only on restart, and it can be only once on restart. We have a lot of possibilities. I will not go here in all the details. Now we come back, and that's interesting. In the version 1.0, we can log an entity. Maybe you remember that at operations I have informed you about this logging. But logging an entity means all or nothing. And you see here in this that we have here operations, we have data and so on. And I can here with the scope clarify with the scope calibration. You see I have here a configuration included, and I have included an execution. So the other operation and the data is not included. A second client can use this. That's the advantage of a scoped log. Yeah, and now we have also introduced the in-vehicle communication logging. That's if you want to have the traffic which is really running, for example, on your favorite UDS protocol. You can use it and you can archivate this. By the way, the configuration of the logging is not defined from us. We have here the same. We have only an API where you can activate and deactivate. This means the configuration is not standardized and the log format itself is not standardized, but you can use it over different suppliers. Other functionality which we have introduced in the version 1.1 are the possibility to start and restart entities, to shut down an entity, and to clear data of entities. This is restricted to the entities, components, apps, and functions. We have also the possibility to reset configurations to default values, and we have introduced that data can be transported via streams. So we come here now to the summary, and this is the picture which we have seen at the beginning. So you see on the left side where the basic services are now in the 1.1 new, the access to the legal diagnostics. On the right-hand side, you see the trigger-based access, the cyclic data access. Here on the classic features, nothing has changed. We have in the HPC related features, the in-vehicle communication logging was coming, the start, stop and restart of entities was coming. We have the logging enhanced with the scope log, and we have here introduced the scripts. Now we will speak about the collaboration with ISO. The standard, the SOVD standard, was developed by the ASAM members. It's really an international standardization because we have participants not only from Germany, there was colleagues from Japan involved, we have people from England, from Sweden, from US, so it was a bright authority. But for the regularity authorities, an ISO standard is requested, and that's why we look inside. The work is there not so easy, because first of all, and let me start here, you see that our ASAM SOVD standard is split in 3 parts. And the part 3 is more or less the API, which we have looked more in detail. The part 1 are general information, and the part 2 describes the use cases. Use cases like access to faults, like reading of data. And you see the problem here in the ISO that is running in the TC22 SC31, but in 2 different work groups. So there is the work group 2, which is responsible for the part 3, and the work group 6, which is responsible for the part 1 and 2. And there is strongly a strong required alignment with the extended vehicle, which is this ISO series 77, 78 and 80. The 77 is the methodology, the 78 is the web services, and the 80 are the remote diagnostic support. And we have started in such a way, and you see it here, this in the part 3, and I start normally with this, you will see it's more or less the API description, which is starting in chapter 6 or 7 in our document, and the use cases especially are written in such a way that they are independent from our part 3 or SOVD in general described. So you can also use different solutions. And yeah, part 1, it's very generic description, not so interesting. Interesting is this picture, because this picture shows you the relation to the extended vehicle. And first of all, you must understand that the extended vehicle is not only the vehicle, it's normally a combination of the vehicle with the OEM back cloud. And there you have the access via the extended vehicle services. And you should know this remote diagnostic use cases was preliminary focused on ECUs and not on HPCs. That's why you see that it starts here, and the left-hand side is open, because here we have more functionality in SOVD. Some people say also, and I have shown you that we can make fleet management. That is not diagnostic, but we can do it with SOVD. Always in case that the resources are described and we have the credentials. And you see here, especially the co-located use cases are from the left side. That's why it's here such introduced as a L, and the remote diagnostic use cases. And there we come to the timeline. And the timeline, so you know, version 1.0 was released July 2022. In AUTOSAR, the support, that it is supported from the Diagnostic Manager, was done with the release 11 in 23. In August, we started to hand over a first draft to these work groups. The review is just now running because ISO have required more time. And I think beginning of November this year, we will hand over then really the document as this to the ISO. And now we must follow. And that's why this time seems not really realistic anymore, because we have to follow the ISO procedure. And the ISO procedure says it can need till to 3 months till ISO publish this document. And exactly when this point of time, if it is 1 month or 3 months, nobody knows, is coming, then the so-called ASAM public review is started. And this review via the different countries in the world runs 12 weeks. So our public review will also run 12 weeks. And afterwards, we have to make the evaluation. We hope that there is no technical feedback, because in case that there is a technical feedback, that this procedure must be repeated. And afterwards, the release will take place once as ISO and once as ASAM. Thank you very much that you give me the possibility to present it. And now it's the time for questions.